With that, we're gonna remove you and say see ya. So our next talk we have is from Steve Judd. So he is at JetStack. He's a JetStack consult. And he's going to be talking about intentional platform engineering. So dodging pitfalls and embracing best practices. And I really love that we're using dodging pitfalls, avoiding those pitfalls is really good. So with that, I'm going to add Steve in. Ooh, I added his slides first. Now I'm going to add Steve. Hello, Steve.
Hi.
Welcome.
Hey, good to see you. It's been really interesting so far.
Where are you joining us from?
The UK.
Lovely. We love it.
So deeply grateful that I can speak in my first language, since any other I'm rubbish at. So.
Well, well, with that, we will let you take it from here. Thank you so much for being here, and we're going to duck out now.
Brilliant. Okay, hi everyone. My name is Steve Judd, Technical Director at JetStack Consult. Basically JetStack Consult, we're a small boutique consultancy that have spent much of the last decade helping teams and organizations get the most out of their investment in cloud and Kubernetes. And I think, it's fair to say that Kubernetes and the ecosystem has matured greatly over this period. And certainly when I started at JetStack about 4 odd years ago, most of the engagements tended to be about helping teams get started with Kubernetes. But those kinds of day zero and day one challenges are mostly solved now, I think, especially if you're using one of the cloud providers' managed Kubernetes services. So what that's meant is that in recent years, we've spent much more time helping organizations solve their day two challenges. And that's really what I want to focus on for this particular talk, is how to kind of describe some of these problems and how perhaps they can be mitigated or avoided. So hopefully these particular day two challenges on the screen resonate. Hopefully they resonate with you, or at least some of them. I think if your use of Kubernetes is fairly mature, then I would expect you to have at least one, if not more, of these challenges. And if you're new to Kubernetes, then I'm reasonably sure that these challenges will become part of your future at some point. So the sad news is there are no silver bullets. I can't give you ultimate answers that will solve all of your Kubernetes problems, or even some of them. But what I'm hoping is that some of the patterns that I'm going to talk through and the approaches, hopefully they will give you some ideas and some pointers about how you can kind of mitigate these sorts of challenges. So there's 3 areas that I'm going to focus on over the rest of this talk. The first of which is around troubleshooting. And clearly, when you've got some kind of outage with one of your clusters, you want to be able to very quickly try and identify the cause so that you can fix it. And I'll be talking around a couple of patterns that will help accelerate this process. Then I'm going to move on and talk about upgrades. I'll be honest, I haven't met a platform engineering team yet that enjoys upgrading their Kubernetes clusters. I think it's fair to say that it's a stressful and somewhat time-consuming exercise. But what we've done in JetStack is worked with a number of teams and helped them design processes to make upgrading less stressful and risky. So I'll be talking about those. And then finally, I want to talk about left shifting infrastructure as code. I think, it's quite clearly a good thing to empower development teams and create a DevOps culture, but you can't wave a magic wand and it will magically be so. I think the secret, or part of the secret, is to create an intentional internal developer platform. And so I spend the last part of my talk discussing what this means in practice. Okay, so first of all, I'm going to talk about troubleshooting. So one of the first things that you need to identify when there's some problem with your cluster is whether anything has changed recently, and if so, what has changed and when did it actually happen. And the quicker you can do this, the quicker you can figure out whether that particular change is the root cause of your problems or your outage. So having a single source of truth that holds all of the changes that have been applied to your cluster, I think by definition will make it a lot quicker to identify what changes have been made and when. And in my opinion, I think this is one of the reasons that the GitOps pattern has become so popular. I'm sort of assuming that most of you on this have been or are familiar with the GitOps pattern, but for those that aren't, basically what it's all about is you have a Git repo that holds the desired state of your Kubernetes cluster. And this state could be in the form of pure Kubernetes manifests, or it could be Helm charts and values or customized templates or something of that nature. Then inside your cluster, you have some kind of GitOps operator, which could be, typically it will be Argo CD or Flux2. And that operator is responsible for identifying new commits to your Git repo, pulling them into the cluster, and then turning those desired state changes. So perhaps if it's a Helm chart, it will actually hydrate that Helm chart with the values supplied, and then it will be responsible for applying those changes into the cluster. So basically turning your desired state into actual state. And having this desired state in a Git repo means that basically each change that you're making to your cluster is going to be recorded as a commit so that you can tell what was changed, when it was changed, and by whom. Having said all of that, I think an approach that I see quite often to the way that GitOps is used is leaving the rendering of those Kubernetes manifests to the GitOps operator. So what I mean by that is, for example, if you're using Helm, then perhaps in your Git repo, you specify the chart that you want to use and the values for each of the environments, and then you leave it up to the Argo CD or Flux operator in your cluster to basically execute Helm internally to render those manifests and then apply them into that cluster. And the reason that I'm not enthusiastic about this approach is that you're not really certain what changes are actually going to happen to the cluster. So you don't know what secrets might get changed or what deep deployment or pod resources or specs are going to alter, because you're not seeing that in your Git repo. You're basically depending on the Helm template command or the Helm install command happening by the operator. So when you go to look at your Git repo, you're not entirely sure what it might have done. So you'd have to then spend some time either interrogating the output from the GitOps operator to see what happened, or perhaps what you could do is run your own manual kind of Helm template command locally and do a diff. But as I said, this is kind of a time-consuming exercise. And so I'm a big fan of a slightly different pattern called the rendered manifests pattern. And essentially, the way this pattern works is it makes a CI pipeline responsible for rendering your Helm charts or customized templates rather than the GitOps operator. So the way this, if I talk you through this diagram on the screen, basically you've got your platform engineer and they'll make some configuration change to your source of truth Git repo in the main branch. So perhaps, for example, they might update the version of a Helm chart. This then gets picked up by a CI pipeline, which runs the Helm template command for each of the different environment values files, generates the Kubernetes YAML files out from this Helm template command, and commits those into individual environment-specific branches in the same repo. At this point, your various GitOps operators running in the different clusters will notice that there's a new commits into these environment branches, sync sync the manifests, and then all that the GitOps operator is now having to do is basically just apply those pure Kubernetes manifests. So you've taken the responsibility of doing Helm template or Helm upgrade away from the GitOps operator and given it to your CI pipeline. So as I said, I really like this pattern because I think there are a bunch of benefits to it. First of all, it makes it really obvious what changes are going to be made to your cluster before they are actually made. And of course, you can use diff tools to see exactly how so that you can compare what the previous state was with what the new state is going to be, for example. Secondly, because your GitOps operator needs to do less, it will perform better. Now, the GitOps operators on small clusters, you won't really notice much performance difference. But as your clusters get larger and more complicated with more workloads and more configuration changes, then the resource requirements that you for your operator in terms of how many CPU, how much memory, they will start increasing quite considerably. And at the same time, the actual working of your operator will start to slow down because it's having to do more work. And then finally, the other benefit that I like is that because you've got these different environment branches, then of course you can set different policies for those branches. So if the templates are being committed into your dev environment branch, then you might just let them get committed straight away and picked up automatically. Whereas for your production branch, you might introduce a requirement to do it via a pull request or a merge request and have some human reviews reviewing what the changes are going to be. Then moving on, obviously there are going to be some disadvantages to any of these sorts of approaches, and the first obvious one is that you're adding some complexity into your CI pipelines, as they are now responsible for doing the kind of template hydration, if you like. And then the second kind of if you like, the con of using this approach is that you might have to change the way that you handle secrets, because clearly you don't want to be storing sensitive values directly in your Git repo. So you might want to be thinking about using something like external secrets operator to do the secrets management instead. If this pattern has any appeal or interest to you, then I would encourage you to read the blog post with the link that I've put on my screen. I think it gives a great, very in-depth write-up about this rendered manifest pattern, far more than I can fit into this brief bit of my talk. Okay, so moving on. So the second thing that I want to cover is all about the pain of doing Kubernetes upgrades and the add-ons that you've got in your clusters as well. So I think it's fair to say that an upgrade process is quite time consuming, and clearly the more clusters you've got, the more time consuming or toilsome upgrading those clusters is going to be. And certainly in my experience, many of the platform engineering teams that I work with kind of basically try and put this upgrade exercise off for as long as possible. So just a quick refresher for those that maybe aren't familiar with how often you get Kubernetes releases. The upstream CNCF Kubernetes project do a minor release every three per year. Each of these releases is supported for 12 months. Then you have various downstream managed distributions like GKE, EKS, OpenShift, and so on. They have their own cadences. And then, of course, on top of that, you've got all the add-ons that you might have in the cluster, like Cert Manager or Prometheus or Istio. And of course, they have their own release cadences. So something that we've used with a few platform engineering teams to help kind of demystify this upgrade process and break it into manageable chunks is to define an upgrade timeline. something that shows when you can start assessing the impact of an upgrade through to the point when it has to have been completed. So I'm going to go through a couple of examples of these release timelines. And the first one I'm going to use is one for GKE clusters. And for those not familiar with GKE, it has the concept of release channels. So you can subscribe your clusters to one of these three release channels: rapid, regular, or stable. And if you do subscribe to one of these channels, then it will get automatically upgraded a certain number of months after the upstream release of a particular Kubernetes release. So the table at the bottom shows what this release cadence looks like for the different channels. So basically, the sort of standard best practice is you would put your dev clusters into the rapid channel because they're the ones that get upgraded quickest after a new Kubernetes release, whereas the stable one is the longest amount of time, and therefore you would probably want to put your production clusters in there. So this timeline schematic on the screen really is trying to show the platform engineering team how much time they would have to assess and test their clusters for problems when upgrading Kubernetes. So as you can see from there, it's really 3 or 4 weeks after a Kubernetes version is released. It's now available in the rapid channel. So at this point, the platform engineering team can start doing their testing because they can immediately choose to upgrade their dev cluster or in fact build a new cluster, start their assessment, their testing, perhaps do some mitigations, test those, so that and the point of the timeline is it shows you basically how much time you've got in terms of months or weeks before you need to sort of actually have everything ready so that the auto upgrade can successfully kick in. Although I should also point out that you're not forced into upgrading at a particular point. You can block an auto upgrade from happening by specifying an exclusion for a cluster if you're not yet ready. So it's not quite as sort of set in stone as it might appear. So this is one approach to doing a timeline. And the next one I want to show you is a little bit simpler. This one we've used on EKS. And the thing about EKS releases is that Amazon don't actually have any auto upgrade feature that I'm aware of. So the onus is on you to kind of take a particular EKS release and upgrade your clusters yourself. But you still need to create this sort of timeline. So on this one, you can see that a team would probably have around about 14 months to assess a particular EKS release, make any mitigations, and do some testing before they're now ready to deploy it and upgrade their cluster. I should also note that AWS provide this extended support extension for up to 12 months. So at the point when an EKS release goes out of standard AWS support, it goes into what's called extended support. So you've got another 12-month window. That being said, it's worth mentioning that you do pay extra for this extended support. So just to sort of wrap up this particular section about upgrading, this is kind of the sort of process that I sort of encourage you to think about, or at least the parts of when you create a process, what you might want to consider. So we've gone through creating some kind of runbook or process with a timeline for doing the upgrades. I would encourage you to sign up to receive some notifications of new releases, whether direct from CNCF or if you're using a managed service, then they will certainly provide you with notifications. I think it's important that you have that you badger your dev teams to provide sufficient test coverage so that when you do your tests of the applications in the new upgraded cluster, you can make sure that you can be confident that your tests are covering all of the sort of vital aspects of those applications. And then the final thing that you need to consider is how you're going to approach upgrading the add-ons. And what we've sort of discovered over the course of helping teams do these sorts of upgrades is a couple of different approaches to upgrading add-ons. The first of this is where the platform engineering team has created, if you like, their own Kubernetes platform, which is versioned. And this Kubernetes platform will consist of a specific Kubernetes release and specifically releases of the add-ons that they want to put in their cluster, or they do install in their cluster, such as Prometheus or Grafana, Cert Manager, and so on. And so when it comes to perhaps they want to create a new platform version which has got a newer release of Kubernetes and or newer releases of the add-ons, then they will do that in a new versioned Kubernetes platform. So that's one approach. The other approach is where you really just upgrade the add-ons as and when new versions become available that you want to take. So you're really doing it in a much more fluid way and dependent on the different cadences of the various add-ons that you use. I think there are pros and cons of either approach, and I don't really have a strong view about which is sort of better or worse. It really boils down to the sort of ways of working and culture within your platform engineering team. So finally, I'm going to talk about giving development teams more ownership and responsibility for the infrastructure and platforms that actually host their applications. So I think it's fair to say that the era of software-defined data centers is certainly upon us. And whether you're using a cloud provider like AWS, GCP, or whether you're using something like OpenStack or VMware in your own data centers, thanks to the raft of APIs and tools like Terraform, then pretty much any engineer with the right access and permissions and some expertise can provision servers and databases, networking, Kubernetes clusters, and so on into this kind of infrastructure. And I think clearly there are some great benefits to this. You're empowering your development teams, and hopefully you should be reducing bottlenecks because they're no longer dependent on your platform engineering team or an operations team to install servers, install databases, and so on. That being said, there are a bunch of risks that come with this as well. You're kind of imposing some extra cognitive load on the development teams in kind of areas such as infrastructure provisioning that they might not have very much expertise in. You're inviting the opportunity for greatly increased tool sprawl. And I've seen this in organizations where they've got multiple dev teams and they're basically given the remit, you build it, you run it, you own it. So of course, these individual development teams create their own solutions for problems like infrastructure provisioning, building their applications, deploying their applications, and so on. And the chances of each team coming up with different solutions are actually quite high in many organizations, hence the fact you get this tool sprawl across your organization. And then finally, you run a risk of a reduction in quality due to the sort of ignorance and time constraint that the development teams are working under. And where this might materialize is perhaps the security and efficiency best practices are not quite as good as you'd like them to be. So how can we deal with this? What sorts of things can we put in place to kind of try and mitigate some of these risks that I've just been talking about? Well, I think one of the answers is to create intentional internal developer platforms. And I realize it's quite a bold statement to say these are the solutions, but bear with me over the next few minutes and I'll try and convince you. So I think the first point that I want to make is borne out by this quote from Sasha Rosenbaum, which is basically if you're running software in production, you're running it on top of some kind of developer platform. And that platform may be something complex and involve a lot of tools, or it could be something really simple and involve a tiny bit of Terraform, some bash scripts, and a runbook documented in a wiki. And the point is not which is the best option, it's which is the best option for your team and your culture. And really, if you're running this, if you've developed this development platform in a kind of organic and unplanned way, then the chances of that architecture being reliable and robust and fit for purpose are sort of much less than if you've intentionally designed and developed that platform. So this is why I'm pushing this idea of intentionality, where you purposefully and deliberately design and develop your IDP. And hopefully now that you're getting super excited about what that really means, I'm going to talk about what the components are that you need to be thinking about with any IDP. So first of all, you've got a portal. Every development team that I've ever met loves a nice UI. And Backstage is an obvious example of one, although Argo also produces a nice UI, and of course you've got commercial offerings to look at as well. But equally, it could be something simple, like just a web form, or even like a Jira form or something. So it doesn't have to be a full-blown UI. Next, I want to just talk about the various implementation providers. So these are essentially providing you with APIs or wrappers, SDKs around APIs that actually do the provisioning into the infrastructure. So Terraform is a really obvious example of one, although there are others like Crossplane's another one, CDK, and then GCP's config connector. And then we've got the orchestration component. Now, often this is a CI pipeline which executes a bunch of Terraform modules, possibly with some Bash or Python to do some further configuration. And that pipeline could be a GitHub action, or it could be something in Jenkins or GitLab. And that's pretty common that I've seen over the years. But probably more recently, let's say in the last couple of years, there are more purpose-built orchestration tools coming onto the market. And a couple that have appeared that I'm quite fond of and I think are very interesting. One is Crossplane, and another is from a startup called Syntasso, and it's called Gratix. And basically, these purpose-built orchestration tools provide you with the ability to template higher level of abstractions to enable you to define entire platform environments really within one of these templates. So Crossplane refer to them as compositions, and Gratix refer to them as promises. But the point is, with this, you can have one template, which is perhaps the one that you allow the development teams to use, and within it takes care of provisioning some networking, some firewalls, maybe a Kubernetes cluster, and some database services as well, for example. And then finally, I just want to mention service catalogs, because I think these are something that people don't pay enough attention to. But as somebody that gets onboarded to lots of different platform engineering teams, it really, really helps when you can go to a catalog that shows you all of the services that are kind of provisioned and available, and all of the templates offering you the things that could be made available. So this is my shout out for paying more attention to maintaining a decent service catalog. So I've carefully avoided talking about specific tools, but what I want to say at this point is there are a huge number of tools in this space, perhaps quite a daunting number, in fact. So I think a good place to start wrapping your head around development platforms and the tooling and the processes and the design patterns and so on is to go to the platforms working group, which is part of the CNCF's app delivery tag. And they've written up a couple of white papers, one of which is their platform engineering maturity model. So if you're interested in this, I would definitely go and have a look at that white paper. The next thing that I think is worth talking about is a project called Canoe, which is Cloud Native Operational Excellence. Again, sponsored by the CNCF, and they are aiming to provide a comprehensive collection of IDP patterns and information. And they also have started work on a few reference implementations using some of the CNCF open source projects. And then finally, this might not be the only one, but it's an opinionated IDP stack called Backstack, which consists of Backstage, Argo CD, Crossplane, and Kyverno. And I'd certainly, even if you're not interested in using all of those tools, I'd go and have a look at it to see how they've combined them and the kind of challenges that they've faced and overcome. And then finally, of course, there is a wide variety of commercial products. Just a quick Google will find them. So that really brings me to the end of my talk. So I've covered some approaches to helping you with troubleshooting outages in your cluster by, really consider moving the responsibility for rendering your manifests from a GitOps operator to inside a CI pipeline. I've talked about how the pain of upgrading Kubernetes can be somewhat mitigated by taking the time to map out a process and the timeline. And then finally, I've been talking about left shifting infrastructure as code, so that you can, basically improve your development life by providing an intentional developer platform. So that's really the end of my talk. Many thanks for listening. If you've got any thoughts or questions, then I'll be around to answer them. So thank you for your time.
Thank you so much, Steve. That was really a great talk. I really liked how you started out with saying you either said silver bullet or magic bullet, and then I couldn't remember what you said. I was like, it's silver or magic, silver or magic.
Silver bullets, yeah.
And I thought, it's really interesting around cognitive load. We are, obviously a lot of organizations are talking about cognitive load because it's hard to remember every single thing that you need to remember.
I think it's really unfair to expect development teams to do that. They've got their own priorities. They're trying to push out features as quickly as possible. So to expect them to have to, frankly, understand the plumbing in any great depth is kind of unfair.
Yeah. And your talk did such a good job setting up a bunch of the talks that are coming. You mentioned the Canoe project, which is great. We're going to hear more about that later. You mentioned Cradix, which I'm pretty sure Abby's going to come on and talk more about later.
We know each other quite well. So it's perhaps it wasn't entirely deliberate, but because I knew what was coming, it was great to be able to kind of get in and sort of plug them because they're
we love it. It's tying, this is a community event. We love it when everybody's tying it all together. But it's like we have a lot of the same questions and we're all trying to solve the same problems. And I just love how we're getting together with these open source technologies, like some of the ones that you mentioned. And I guess if I have one question for you while we have like a couple extra minutes, how much are you leaning on open source technology and contributing it, in open source communities? And obviously the CNCF has a lot of initiatives around here, but how do you see that playing a role, and how can other people get involved who really want to?
Wow, big question. So I think so, and I'm pretty certain Abby will talk more about this, is I think one route into it. So obviously, if you're a great kind of Go coder, then that's a route. But many of us only dabble in Go code, but there are a lot of these tags, all the CNCF tags, and within those are a variety of working groups, and I kind of alluded to one of those in one of the slides. So, and that doesn't need you to be a coder. If you're an architect or if you're just interested, then like I said, the platform engineering working group, they wrote a couple of white papers, and that was done by a whole bunch of people collaborating and figuring out what was important. No code required. That's just having a point of view, opinions, and being prepared to sort of sacrifice some time to be able to kind of for the greater good, really.
And I love that. I was fortunate enough to work with Abby and on the platform maturity model, not in it, but actually providing a little bit of insight because we had worked, I had worked on the cloud native maturity model with a working group. And so we were working together to align and making sure our maturity models mapped. And so all of that is super important. And again, no code required, as you said, but offering the insights that we all have to the community.
Absolutely. Yeah. Long may it continue.
Well, Steve, thank you so much for joining us today. It was a pleasure to have you on. With that, I am going to kick you out.